So I see that participants are coming in. And then at 1 sharp, we can begin. Yes.
We have problem with connection.
No?
Connect. How do you put me in?
Yeah, now we are live. Yeah, hi, Eric. I guess you cannot hear because we have not started yet, but you can right now if you can hear my voice, please. Okay, thank you. We will start at in 3 minutes. 1.
We cannot connect. Try again.
Okay, so I think we can start. So welcome everyone, and thank you very much for joining us in the webinar Smart Aquaponics and the Groove project. The webinar is offered by the project Aquaponics in Roslagen. So today we have the pleasure to have with us 2 researchers from the University of Liege, Nicolas and Ancion, that will present us a project about a case of urban farmer bankruptcy, and Pierre Raulier, that will present the project Smart Aquaponics and the digital tool that they are developing. But before starting, I just remind you that this webinar is being recorded and then it will be available on our webpage. I also ask everyone to keep the microphone muted so that we can all have a good webinar. And also you can write your questions in the chat. I'm going to write there. Actually, I saw that some discussion already started. And then every lecturer will answer to the questions after his presentation. And we will try to answer to as many questions as possible. But first of all, let me introduce ourselves and who we are. So today it's me, Donatella Acquaviva, and Amelia Morin-Stromberry, she's online with us, organizing this webinar. We work at the Utvecklingcentrum for Vattens, department of Campus Roslagen, a municipal company in Norrtälje in the Stockholm County. So Amelia is our operational manager. She has 30 years experience in water management from different enterprises. And I am a project manager here in UCB, and I am the project manager of the project Aquaponics in Roslagen. And my focus areas are eutrophication, circular water economy, and aquaponics. But what do we do here at UCB? So we run and partake in projects dealing with sustainable use of natural resources, groundwater quality and availability, and eutrophication. In particular, eutrophication is a phenomenon that happens when there is an excess of nutrients in water bodies. This leads to an increased plants and algae growth, and this process results in oxygen depletion and eventually to the death of the water body. Some of the main contributors to eutrophications are agriculture, leakage from animal waste, and also on-site wastewater systems. So here at UCB, we have several projects dealing with eutrophication. For example, we work with wetlands restoration and constructions. We have a project regarding the sewage collecting system for leisure boats. And we work a lot with the on-site wastewater systems. So we have the counseling service for the municipality of Norrtälje, and we also run projects. And also our latest projects about aquaponics. So very briefly, what is aquaponics? So aquaponics is a circular farming method where you grow aquatic species and you use the water, the nutrient-rich water from the fish culture to grow vegetables. And then the clean water comes back to the fish. And in this type of system, you have to provide energy. This is very quickly, but also I will provide you several links where you can start studying about aquaponics if you're interested. But why did we decide to start a project about aquaponics? So there are several challenges that the food sector today has to face. For example, social challenges like an increasing world population, environmental challenges like eutrophication, as I mentioned before, and agriculture and aquaculture are main contributors to this phenomenon. And also we have to think that agriculture, more than other sector, is affected by climate change. Then we have to consider that Sweden is strongly dependent on food imports, especially for what regards fish, fruit, and vegetables. And aquaponics can be a way to grow even species that we have to import nowadays, even at the center of the city. And also we have to think that we humans as a species are overusing our resources. So our seas are overfished, and also intensive monoculture agriculture is leading to the depletion of soil nutrients. So that's why we decided to start a project about aquaponics. Our project started last year in October and will run until March next year. It is financed by LEADER, the Rural Development Program of the Stockholm region, the Swedish Board of Agriculture, and Roslagens Sparbankstiftelsen. What we are doing very quickly in the project. So we have built a demo system where we are growing tilapia and spices. We have two types of beds, the deep water culture and the media bed. We are doing dissemination activities. For example, these webinars are part of these activities. We did study visits before Corona, and also we will publish a short technical report by the end of the project. And also we have education activities. So we have activities for schools, like study visits. We are going to launch a website on the 20th of November for schools. We did a mapping of existing education, and we also applied for a 2 years professional education after high school. And finally, here there will be some useful links that I will share with you in the follow-up mail. In particular, in the literature, you will be able both to download some open source handbooks and also to find recommended books. But now I stop sharing my screen and I leave the floor to Pierre.
Hello, nice to meet you all. So we'll first share my screen. So do you see my screen now?
Yes, perfect.
So my name is Pierre Raulier, and I'm working in Belgium, in a Belgium university called Liege University, which is here. And in this university, I'm working in a research center dedicated to urban farming. So its name is Centre de Recherche en Agriculture Urbaine, which is a French name of Research Center for Urban Farming. So in this research center, we are working, studying all the different techniques that can be adapted to urban farming. So we investigate low-tech and high-tech techniques, and we try to see where they can fit, and we can to develop and improve them. So here, I will just give you an overview of which technique we are working on. And actually, to show you this overview, I will show you a research platform where we have different kind of tools that can be used to carry out our research. So you can see on this map, there is a map of the platform, which is 2 hectares big. And there we will find some gardening and horticultural device. We'll find 2 aquaponic systems. We grow vegetable in containers, and we will have a rooftop greenhouse. So I will show you all of them. So here on the slide, you can see our experimental platform for gardening, but also for permaculture. In here, you can see one of our aquaponic system. So this is the biggest aquaponic system we have. So it consists in actually 3 different aquaponic systems. And each of these aquaponic systems have 3 cubic meters of water for the fish part. And we have between 6 and 10 square meters of crop for each of these systems. So since we have 3 times the same aquaponic system, we can replicate and explain scientific research on this. Here we have another aquaponic system, which is actually a small greenhouse in a small container. So we have 2 cubic meters of water here, and we have 20 square meters of vegetable here. The main research that we are doing on aquaponics are dedicated to identify what kind of living organism and organic material are present in the water, and to see if they have a positive effect on the plant, on the fish. And it seems that there are some positive effects. We are also working on the recycling of the fish sludge to create some fertilizer for the plant. And we are trying to adapt some new species to aquaponics. Then here you have a picture of our future rooftop greenhouse. And the last device we have are some containers, indoor container. So there we try to work on a medical plant and try to find the environment and the environmental condition that help to create to have the better crop and to produce more drug, as much drug as we can. And also we work on the quality of these drugs. So if you want to follow our activities, we have a website, which is here, and we are present on Facebook and LinkedIn. So if you want, I really invite you to follow us on these 2 social networks. So.
Okay, thank you, Pierre, for the presentation of the crowd of the research center.
Thank you very much.
Now we can listen to the presentation of the group project from Nicolas Ancion. Please, Nicolas.
I think.
Does it work?
Yes.
Perfect. Thank you very much, Amelia and Donatella, for inviting us today. So my name is, oh, I will put it full screen, better like this. My name is Nicolas Ancion. I'm working with Pierre in the University of Liege. So for the research center in urban farming linked to the agronomical faculty. And I'm working also in the Smart City Institute, which is a research center linked to the business management faculty. And for both of them, I'm working with Pierre for the Groove project, which is a European project funded by Interreg, Northwest Europe. And Groove means greenhouses to reduce CO2 on roof. So the main objective is to reduce CO2 in the agronomical sector and the building sector through rooftop greenhouses. So the main aim is to optimize the energy exchange in circular economy between a building and a rooftop greenhouse. And I'm working mainly here as a project manager and in the business strategy part of these rooftop greenhouses. And today so Donatella joined us to talk about the bankruptcy of urban farmer. I don't know if I have access to the chat. Does some of you know urban farmers? But I don't see the chat.
I can comment when the answers will come. Someone is already answering yes. Someone
okay.
no. So we have a mixed audience.
Yeah. So basically, we weren't part of urban farmers, but as we are an international project with a lot of competencies in our team, we are working with architect, agronomic engineer, building engineer, business engineer, etc. We are building ourselves rooftop greenhouses. As Pierre showed you, we are building one also in the University of Liege. And we are coaching entrepreneurs who want to build a business around a rooftop greenhouse. And when we learn about urban farmers, we first visited in 2017, I think. And we heard about a bankruptcy in 2018. So the process here and our objective was to study this bankruptcy with the information that we have, because we never went in an administration council or general assembly, and we weren't in the operational day of life of this company. But we try as much as possible to understand this bankruptcy, why they did it, and how to prevent it in our project. And what I will present it now is the history that we could gather and our conclusion. And I will be happy to discuss it with you afterwards. So in a nutshell, Urban Farmers was created in 2017. It was almost 3 million euro of investment to build it. And the size of the greenhouse was a little bit more than 1,000 square meter. Production speaking, they were planning to produce 20,000 kilo per year of fish and 50,000 kilo of vegetables. And there you can see the picture of the rooftop greenhouse that they have in The Hague in the Netherlands. Regarding the strategy, basically we will see it afterwards, but basically in the timeline, they first interviewed few potential customers. They opened the rooftop greenhouse based on the B2B business strategy. After a few months, those clients stopped buying for reasons that we will see. They try to change the strategy then to the B2C. So it's a consumer directly selling strategy, and they also diverse the activities doing not only production, but also services as location for business, meeting, etc. Unfortunately, none of those one works as they went bankrupt in, unfortunately, in 2018. When we gather mainly in information on internet and also a few meetings with one on the co-founder of Urban Farmer, which is Andrea Graber, as they did in the B2B strategy, interviewed potential customers. Unfortunately, apparently they didn't make a trying period. They did have a production test, but in Switzerland. So it wasn't exactly the same environment. And apparently they didn't really understand the real needs and how to work with the potential consumers here in B2B strategy, which were restaurants and canteens. So the strategy didn't work. They tried to change it. It's normal when something go wrong, the business is going on, you need to make decision to keep going the business. So they choose a B2C strategy. They were selling directly tilapia and tomatoes. They also, as I say, and a lot of vegetables, but mainly tomatoes. And as I said before, they diversified into services, not only product, but into services, but making conferences, renting meeting area, make visits of the greenhouse, rooftop greenhouse in our case, and also making direct selling. Unfortunately, as it went bankrupt, this didn't work. So we were asking why. What we analyzed was that this rooftop greenhouse was really close to the sea and close to a tremendous amount of other greenhouse in Holland, in the Netherlands. And in these greenhouses, they are already producing a huge amount of tomatoes. And the price was completely different. I think the market price for these tomatoes was €2 per kilo, and Urban Farmer was selling it to 6.5 to €8 per kilo. So these consumers in the B2C, the direct selling to consumers in this B2C strategy, were people who apparently it was a neighborhood with a lot of money. So basically, as we said, they were price oriented. So the decision was based on the price, and the price of urban farmers was way heavier than the market price over there. So they had already access of a lot of tomatoes and cheap vegetables, but also it was close to the sea. So they had already also access to a lot of fresh fishes. And no tilapia, because the tilapia is an African fish, which is usually used in the aquaponics system because they are easy to grow. Nevertheless, it's not really adapted in Europe because we don't know tilapia very much. I mean, in this area at least. And furthermore, in the Hague area, they are close to the sea, so there has already access to a lot of usual fish, very fresh fishes. Regarding the competition environment, I just said a few words before, but yeah, mainly conventional grower producing soilless vegetables, and yeah, 35 million of square meter of greenhouse just next to it. And they were low price leader. So this was for the business strategy. Regarding the production also, we analyzed few challenges that apparently hasn't been resolved during the lifetime of urban farmers. the production rate was apparently too low. So this part was mainly a colleague of mine did it, because as I'm not agronomical engineer, but we can have also discussion on it afterwards with Pierre. And they are technical constraint. It's very difficult and very challenging to make a lot of innovation in the same time. They are making a rooftop on a greenhouse, trying to optimize the energy exchange, and also trying to innovate in the production method using aquaponics method. So a lot of innovation means a lot of challenges in the same time, and it apparently grow the failure probabilities. At the end, so the third main part that we analyzed, the first one was the business strategy, which didn't work. Apparently, the second challenge was the production, which apparently was really challenging, and they might not have succeeded to solve them all. The third one that we analyzed was the shareholder agreement difficulties. At first, they had a really complete team with a lot of skills, transversal skills, so production manager, business manager, people with expertise, and they have already tried this job before, so they had experience in it. But after one moment, apparently some difficulties and understanding came along, and some shareholders and so key partners within the company left. And so they left with their knowledge and their competencies, their expertise, which at the end of the day was also apparently a key challenge and a key player here in this bankruptcy. So therefore, the consequences are economics, of course, financial. As we gather these figures, we can see that more the turnover was growing, the more the loss was getting bigger also. What they did is take a product and try to push it in the market. And maybe what they should have done, it's maybe have a better understanding of the environment, and after fine-tune the product and the services through this environment. Of course, this analysis is quite critical, because our objective was really to understand what went wrong and not do the same mistake. But of course, this is a very innovative project. It's a very inspiring project at first, because they succeed to get the funding, they succeed to construct it, they succeed to launch the activity. And as every pioneer and every pioneer's project and method, here they haven't succeeded in the long run, but what they did is still inspiring, and we thought we should learn a lot of this experience. We make, of course, a complete analysis of it. I put the link here. If you want, I can make it. I will send anyway the slides afterwards. So I can, if you prefer to check it now, I can also put the link in the discussion tab. But this is 25, 30 pages, which is explaining deeper what I just summarized now in a few minutes. So I make the overall of the presentation. Now, if I understood well, we can go directly to question about it, right?
Yeah, thank you very much, Nicolas. So let's see if there will be questions. There are no questions so far, but as you said, it's even though it at the end it didn't work well, it's very interesting for the community to see what went wrong and to have the opportunity to study it. But if you could give one of your advices to who wants to start a commercial aquaponic system, what would be your advices?
What we, I don't have the perfect answer, of course, but what we do see in our networks and our little experience coaching project in it is that for now there is no mainstream business strategy which will work, of course, in any part of Europe or in any region. Usually, urban agriculture, in general, urban agriculture has no mainstream baseline instead of environmental and social, but regarding the economic parts. So it's really you really should understand who will be your customers and what do they need. I mean, quite the basic, you will say, but it's a real challenge here because as we see, I guess they have already they have already approached a few canteens and restaurants, and I think it was 12. They all said, yeah, okay, your product amazing, locals, in a circular economy system, it's aquaponics, it's innovative, it's local, perfect, we will buy everything. Apparently, it wasn't true, and we have shown that it's in other projects also, because usually at first sight, this type of projects are really inspiring and interesting. But when you go to the day-to-day business as usual, this product with the high value was the freshness, right? And nevertheless, the restaurants was buying the products. They should have transformed it, for instance, at the moment, because one of the added value is the freshness, but they were putting it in the fridge for 2, 3, 4 days. So at the end of the day, they were paying a product 4 times more expensive. Therefore, they were not using the added value of it. So after a few weeks and few months, the majority of them said, okay, I will return to my other provider, which were less expensive. And the product for me is actually the same. So yeah, really understand deeper how you will do it. And maybe before launching 3 million euro, maybe just go deeper. But of course, it's ever challenge. There is no perfect answer.
Yeah.
I have a question.
Yeah, exactly. There is a question. So how did urban farmers' placement on the roof of an existing building affect the economy of the company? And did it make it more or less expensive for them to partner in that way?
The placement of the roof, Pierre, do you know the bearing of the roof at first for them? Because it's the key challenge here. If the bearing is not, you have to put a structure on it mainly. It's like almost €2 per square meter. Just to put a structure that will be able to get your rooftop greenhouse, so the costs explode. I don't know, for urban farmers.
Concerning the roof, indeed, I don't recall if they had to make some change on the roof, but when you try to make a farm, an aquaponic farm or any farm on the roof, you need to check the bearing capacity of the roof, because if you need to reinforce this roof, it will be extremely costly. So that's the first part of the answer. The second part of the answer is that when you build something on a roof, it will be more expensive than on the ground, just because you have to lift everything, and that all the safety aspect of the construction are more expensive. So basically, it will be more expensive. Nevertheless, due to the fact that it's on a roof, you can make some energy saving by taking the lost heat from the building, but also you benefit from a kind of hype. So you will have a nice visibility and people will visit your place because it's really nice. So this will attract some customer. And then if you have some nice space around the greenhouse, you can rent them and you have another kind of revenue.
Okay, thank you. Then we have other questions. Yeah. So if it is possible to have shrimps in the aquaponic system to boost the revenue and sell the shrimps to sushi restaurants?
It's possible.
I see just an, oh yeah, go Pierre. I see another one, economically figures.
Yeah.
So it's possible to put some shrimp in aquaponic system, and some people does it.
Okay.
The productive shrimp like hot water, like tilapia.
Okay. Yeah, and as Nicolas was saying, there is a question about the economical figures at urban farmers and what were they aiming for economically?
Yeah, I will just complete before what Pierre was saying, and indeed, just food production in a rooftop greenhouse. A rooftop greenhouse is anyway very expensive compared to a greenhouse on soil, on the floor, on the ground. Nevertheless, this greenhouse would be a really marketable also product for you, and economically speaking, you can really reuse. If you succeed to reuse the energy of the building, you would make a lot of saving, which can balance the cost of investment here. Of course, you can do it on the ground if you have a good something that are producing lost energy that you could reuse. But therefore, this rooftop greenhouse is also a huge accessibility and visibility within a city to connect the citizen, and you can also through this make a lot of other urban farming project. And in our project, it's usually the case. So it's almost never a rooftop greenhouse alone, but usually you have a rooftop garden also with it, or garden or urban farming, professional urban farming at the ground of the building. And regarding urban farmer, I don't know the exact economic aim. At least it's true they aimed to be viable. And regarding the product, they are making, or at least they have calculated to make a margin of 20%. So of course, to get this margin of 20%, they had to at least sell 80% of their production, which is a real challenge here. And they haven't reached it. I don't know if I've answered to this question. Do you know how the economical figures was at urban farmer? Then we get this, but yeah, they're making 20% margin. It was maybe not enough. There is an example of studies on vertical farms. How does it stand compared to horizontal food production? Yeah, they are. Pierre, you have maybe a special link to share on vertical farming, but there is the association on vertical farming in Europe. There are, of course, regarding each type of food studies which compared the horizontal production and the vertical production for example, strawberries. So this exists, yeah. This is quite easily accessible on the internet.
And also, with our Groove project, we are creating some description of some vertical farm, and we will release some document explaining how to create a vertical farm and to give some tips to succeed in your project and some example of existing farm. So this will come in the current process of our project.
Okay, thank you. Yeah, then we have other comments and questions. So the first one, I understand the price impacted in the case study you mentioned. How to reduce price of the production and copulate with the existing cheap growers?
So to reduce the price of production, there are different ways, of course. First, there are the scale saving. So the bigger is your farm, the lower are the cost per square meter. That's the first point. Second point is that indeed, if you have a small farm, and you will have higher cost. So there are different strategies. There are some strategies where people are using low-tech farm with really low investment cost. and the strategies that have high tech farm with high yields, but also high investment cost. And what we try to transfer here is that those strategies can work, but you really need to identify who is your client, who will buy them, will they accept to pay it more, to pay more for an aquaponic product than another, and you need to adapt the design of your farm according to what people will buy. And in this context, also, we don't have to underestimate the work associated to the business model creation, and also the communication with the customer and so on. So many people trying to get into aquaponics are mostly interested by the ethical aspect of clean production, or the idea of recycling water, or they are maybe interested by the high-tech aspect. But in many cases, we forget that if you want to make something work, you need to focus on the business model and give nearly as much energy for the business model than for the technical aspect. And I think this will be the key message for this. Mm-hmm.
Then, okay. Yeah.
I can add directly answering the question, what you see, what kind of produce works best in aquaponic. Mm-hmm. But first, aquaponics is still in research, so it's not like conventional agriculture where we know a lot and a lot and a lot. Still, a lot of this type of system is still under research, so everyone is still learning on it. So there is no perfect, I think, but Pierre, correct me if I'm wrong, there is no perfect growing system for this. What we can say first is that the tilapia, regarding the system and the use of the system, the tilapia is made as proof. So if you want an easy one with a lot of data on it, you can try the tilapia, but there is no really, if you want to do it in a professional way, it's maybe not this way around that you should do it, because you can make a lot of tilapia, but if there is nobody to buy you the tilapia, there is no aim of doing it. So maybe it's the other way around. What is the product in your market that you can product and is now available now? Mm-hmm. And afterwards you can say, okay, how do I grow this? Maybe on the other way around of this question.
Mm-hmm. Yeah, and then about the reference material. So in my opinion, the handbook from FAO, the Food and Agriculture Organization of the United Nations, is a very complete reference, especially if you're starting. Myself, I studied with that, and I'm not a biologist, I'm an engineer. So for me, it was really perfect. Then in the link that is in my presentation, there are other references. Then in my opinion, if you really want to go deep, I think you need to be a biologist. So actually then in our team, we have expert biologists that are helping. And then also a good book is called Recirculating Aquaculture, and you will find it in those links. And then there are others. Then maybe Pierre and Nicolas want to add other references.
For low-cost strategy, for low-cost production, it's true. FAO is really complete, but it's a low-cost oriented.
Mm-hmm. Yeah, small scale. Yeah. Mm-hmm. Yeah. Then in urban farmers, did they have any system of using unsold fresh produce in processed food or flash freezing, for example? Could that help to offset losses from unsold fresh produce?
So it could be done, but in the case of urban farmer, selling a frozen fish wouldn't be that interesting, because they are just beside the sea, where there are some big factories that are producing frozen fish. So they couldn't compete. The price of their frozen fish would be much lower much higher than the price of frozen fish from the sea, and the consumer wouldn't see the quality of that. So technically it's possible, but on the market aspect, in their context, it doesn't make sense. It may make sense in another context, but not in that one.
I have another, maybe just an attention point here also, is that in urban farming, at first, when you draw your business, you want to do everything. And one person just can't do everything, can't make the operation of a whole greenhouse, all the aquaponic and the fish, make all the administrative paperwork, generate the business management, the business development, afterward a transformation, for example. So it's the attention point here. It's always to have enough scale operation to make another part of a new operation. So if you want to also transform your product, it's again a new job to learn and to make in place and to make it work. So when you want to make a lot of jobs, it can be difficult because at the end of the day, the week is just 7 days and a day just 44 hours. So if you make another operation, maybe you should get another people working with you to pay it. You will get another scale of operation. You need to get bigger. And it was just an attention point for this. It's usual for urban agriculture to want to do a lot of things. And after it, in experience, we see that after one moment, they try to focus, either really grow and became a big or a medium company, or stay low, but choose your battle. I want to do that, the production, and I'm going already 10 hours per day, 6 or 7 days per week in production. And after I will sell it to a transformer or my neighbor to keep it short and keep it locally. But do everything, it's sometimes challenging, and maybe if you want to do too much thing at first, it can be also a cause of failure. It was just an attention point regarding this discussion.
Yeah. And then can we replace the fish feed completely with black soldier flies?
So there are some companies that are already selling some fish feed based on insect, but nowadays, the day of today, this food is not as efficient as standard food. But within 5 years, I think it will be really common and as effective as normal fish food. So if you are willing to make a large farm, big professional farm, I will not advise to do it, but be ready in the future to go in that direction.
Okay. And then will it be more economical beneficial if we didn't use nutrient film technique and floating raft for leafy greens like lettuce, and use tower design in order to produce more plants per square meter within the same greenhouse?
So the main advantage of NFT or raft is that they are easy to implement and cheap compared to tower. So in that case, it's typically a moment where the business model comes into the game. If you have high cost for the area of greenhouse or land, maybe you will be interested to use tower. If you are in a big field, cheap field, I will invite you to use a system that are cheaper because the land is cheaper. So this is a balance, and this will depend of your location, your farm, and the local cost. But in general, for example, in France, nobody is using them in a professional farm. But when you go in Asian countries, in cities, in big cities, they are using vertical system. So this is the example of sometimes it's adapted to some context.
Okay.
So
I can answer for the next one of the comment about the tilapia. I would say that to make the consumer a new product in your new market, you need a huge marketing strategy and marketing fund. So in your financial plan, you should really work almost half-time marketing, half-time production, because to accept this type of new product, I mean, it depends. Maybe in your area, in the region when you want to sell, the consumers it's already depending from time to time. Maybe if the consumer already are really keen to try new things. If your network is really developed and you just need to send few emails to key player of influencer on Instagram, a key chef, and they are all using the tilapia, and they are really making this this new product process within the market possible for, I would say, low cost. Why not? If you have to build everything, for my opinion, I think it would be really costly, but it's it's always useful to try. It depends of each market, of course, and it was also for the if the main objective is the tilapia of the product. It depends, of course, also, but for urban farmers, at the end, they were planning to make half of the gain from the fishes, a quarter from the events, and a quarter from the fish. So half for the vegetables, quarter for the fish, quarter for the events. At the end, the last strategy, which was a diverse strategy, it's what Andreas Grabers, one of the co-founders, told us. So yeah, 25% for the fishes.
Okay. And then we take the last question now. So if we did a 3D printer for the tower to reduce the cost?
I don't know the price for the printed in 3D. I guess for now it's quite expensive, but yeah, why not?
I don't think on the professional side it will be. If you do it at home, it may be cheaper, but if you want to make a big farm, it will be more complicated, I guess. But I don't know actually.
Yeah. So what is the minimum setup of an aquaponics system, roughly, if you want to start simple in your own house?
So I would say that to have something interesting, you need at least to have 1 cubic meter so that you can produce fish that you will eat. For me, it's personal, but you can have an aquaponic system with goldfish, but the energy, the money, and the time that you will take to take care of the fish part will be really important compared to the benefits, let's say. So I will invite you to take at least 1 cubic meter to put some carp, some salmonides, or even some tilapia if you have some heating capacities, because it will make sense to have an aquaponic system then.
With the FAO information, 1 cubic liter at home, it's really possible to do it. You have all the book and to say each step of how you should do it. So yeah.
Yeah. Here my colleague built it in 1 month, actually 3 weeks. So yeah, it's absolutely possible. Okay, so now I thank you very much, Nicolas.
Thank you.
Are you staying with us or do you have to go?
I'm staying with you. And Pierre and I, we will need to leave in a little bit more than 1 hour at 3 to jump in another meeting.
Okay. And then if there are other questions about this.
Yeah, of course, I'm staying here.
Yeah. So now I think we can go to to the other part, so the smart aquaponics project, and Pierre will present the project.
Okay, do you see my screen? Hello, do you see my screen?
Yes, yes.
Ah, okay, sorry.
Yes, we do.
Thank you. So, as Nicolas said, we are working together on the Groove project, but I'm also working on another project, which is called Smart Aquaponics. And it's also an Interreg project. So it's funded by Europe and also by the French-speaking area of Belgium. So, oops, this project gathers about 10 different associations, and I will present them when I will start talking. So I generally start the presentation with an overview of the aquaponics status in Belgium. So what can we see is that aquaponics appear in the education sector in Belgium. So first, there was first aquaponics system in a secondary school, in an agriculture secondary school. And there they have about 20 cubic meter of water. And I think the greenhouse is between 150 and 200 square meter. Then our university start to have its first aquaponic pilot, which is this greenhouse on a container. And this is one of the aquaponic system I present before. Then after, another research center start to develop its own aquaponics system. And the aquaponics start to appear in different associations in Belgium. So there are 2 NGO dedicated to aquaponics in Belgium, and they are both located in Brussels. So you can see here some really low-tech but really fancy design. And since they are working outdoor or in a small greenhouse, they are mostly working with carp. So they are doing this. And 2-3 years ago, there was a new school that started an aquaponics system for education. And you can see it here too. Then 2 years ago, we saw appearing the 2 first small aquaponics, professional aquaponics system. So one is located in Jardin de l'Usine, and this is actually an organic shop. And behind the organic shop, they have a small permacultural garden, and they wish to put some an aquaponic system to produce some fish, and they are also using some carps because it's easy and really adapted to the climate here. And they use the fish from the aquaponics system, but also the herbs produced in the organic shop. So they directly sell them. The other small professional aquaponics system is in the Atelier de Bossimé. And Atelier de Bossimé is a high-level restaurant. I think they are willing to get 1 star. And there they are growing truths because it's really tasty fish, and it's really adapted to go in a good restaurant when carp is not a high-value fish. So both of these systems have 20 cubic meter of water, and yeah, that is. Then I will present now the big player of aquaponics. So in 2018, we have seen the development of 2 big professional aquaponics systems. The first one is located in the center of Brussels on a rooftop, and it's called Abattoir d'Anderlecht. And you may follow them if you find on the social network the 3-liter BIGH. And this aquaponics system is in a greenhouse, in a big greenhouse, which is about 2,500 square meter. So you can see that it starts to be a big farm. And the second aquaponics system actually is quite interesting because it's a fish farm that's developed just beside a big greenhouse, a big tomato greenhouse. So the tomato greenhouse is about 12 hectares. So I forgot the number of cubic meter of fish, which is in the fish part, but it's really huge, and it's one of the, and it may be the biggest aquaponics system in the world. So the conclusion that we can draw from this picture is that aquaponics systems are really diverse. We have seen some tiny systems, some really huge systems, some low-tech systems, so some high-tech systems, some systems that are commercial or dedicated to education. So there may be different purpose, different technique, and different size. And what my colleague identify when they start developing their first aquaponics system is that aquaponics is a new technology, and they didn't find advanced teaching program for aquaponics. So it's difficult to find high quality information on aquaponics. So it started to be developed now, but 5 years ago, it was easy to find information to make your own aquaponics system at home, but you didn't have training for professionals. And then there were no specific tools for aquaponics. So you can find many tools to make hydroponics. You can find many tools to make fish farming, but there was no bridge between them. So my colleague decided to create a project, the Smart Aquaponic project, that will create different kind of tools that will be collected in one cell phone application. So in this application, we will find a training program, so a teaching for professional aquaponic. There will be a simulator to design your aquaponic system on your cell phone, and then try it and see how what will be the production of your aquaponic system, what will be the energy demand of your aquaponic system, and see if there are some problem in your design and so on. The third tool will be monitoring tools. So in aquaponic system, you may find some sensors in the fish part to monitor the temperature, the oxygen, etc. And in the hydroponic part, you also have sensors to monitor the quality of the water for the fish, the quality of the air temperature, the oxygen level, etc. And the idea is to collect all this information in your cell phone application so that you can see with your cell phone what is happening in your aquaponic system. Also, with this monitoring system, we will be able to run some simulation to see what will happen in your system in the future. So to see what will be the production of your system next month. Also, you can anticipate some accident, like a crash of the biofilter or stuff like that. So we'll now go in detail for all the different tools. And I will start with the training program. So the training program will be a kind of game. And the idea in this game, we will try to give all the theoretical and practical information to be able to create your aquaponic system, but also to maintain your aquaponic system. So in this game, we will start by having a small aquaponic system with one goldfish, one lettuce, and we feed the fish, etc., to get the basis of the aquaponic system. Then we will add a biofilter. We will start to add more complicated components in order to evolve your small system into a professional aquaponic farm. So this is what I try to illustrate with a picture. The second tool is a simulator. So there we will be able to design your aquaponic system on your computer, to run it and anticipate the yield, the production, and the different costs. But thanks to these tools, you can also try different kind of aquaponic system. So you can try a first aquaponic system with no greenhouse. Then you can put the aquaponic system in a greenhouse, see what will happen when you change something, if you had some heating system or not, and you will be able to see what's happened when you change something in your aquaponic system. Then there is the monitoring tools. So thanks to these monitoring tools, in the application, you will be able to see the data from the sensor in your aquaponic system. And the main interest is that you will be able to collect the information from the fish part and the plant part in one environment. So up to now, when you have a professional farm, you have some system to see what's happened in the fish part and some system to see what's happened in the fish part, but you don't have the bridge between these two parts. So now that I have presented the three main outputs of the project, I will present the strategy. So all these tools are based on an informatic model. And this model has the ability to model and to simulate all the components of an aquaponic system. So it's able to model the fish, the bacteria in the biofilter, and the plant. So here, in this illustration, you can see that the fish will grow according to its environment. So the fish will grow according to the food that we give to him, according to the temperature of the system, according to the acidity of the water. And all these parameters will influence the growth of your fish. It will be the same for the bacteria of the biofilter. So the activity of the bacteria of the biofilter will depend on the pH, the oxygen concentration, the ammonia parameters, etc. And for the plant, it will be the same. The plant will grow according to the light, the pH, the oxygen, the concentration of nutrients. And all these elements will grow according to the environment, but they will also affect the environment. So here in this illustration, the fish will grow according to the quality of the water, but it will also release some elements, and these elements will influence the development of the vegetable and of the bacteria. So in our model, we can put the different elements, fish, bacteria, and vegetable, and the model can create interaction between all these elements. And the model is created so that you can add some element in your system. So here, in this illustration, you can see the modeling of a really basic aquaponic system where we have some fish in one tank and a biofilter and some vegetable. But we can increase the complexity of the system to create different fish tanks that are connected to one biofilter and which is connected to the vegetable compartment. So here we could have a model, we can have a model that is modeling a complex farm. And we can, I say before that we are modeling the fish, the plant, and the bacteria. But in this model, we can also integrate a greenhouse. We can integrate a heating system. We can integrate a ventilation system. The model is also simulating the activity of the pump, etc. So this model can model anything present in an aquaponic system, all the components present in an aquaponic system, and create interaction between all these components. So here I have some example of output from our model. So the first, on the top left, I have some simulation of lettuce growth. So here we can see some lettuce that are growing and then they disappear. The curve is dropping, and this means that we harvest the lettuce. So we can see here the growth of the lettuce across the time. Just below, we can see the fish grow. So it seems to be really horizontal. It seems to be aligned. It's because the fish are growing well, let's say. Then we have in the concentration of nutrients in the water. And we can have some key figure with a heat dynamic within the greenhouse, which is a blue line we can see here. And also the temperature in the tank, which is the green line here. So we have created this model, but to be sure that this model is working well, we need to create some interaction between this model and actual aquaponic system. So to do so, we create different kind of electronic device that are able to connect the sensor present in your aquaponic system to the model. So what we did is that we identify in the market what are the sensor systems present in the aquaponic system. So we identify the IKS system, the Oxygal, the Campbell Scientific system, and we create some device that enable to take the data collected by this sensor system and send them on the cloud. Besides, we also create a system where you can directly plug some homemade sensor on a small computer, and this small computer sends the data on the cloud. In the future, we try to get to contact, to work with companies that are also doing some sensing system dedicated to aquaponics and directly send the data from their system to the cloud. So here, there is a Spanish company, H2 Hydroponics, which is creating some specific sensing system and monitoring system dedicated to aquaponics. And we are creating a collaboration where they will be able to send the data online and benefit from the simulation that we are able to create. So here you can see the different aquaponic system of the smart aquaponic partner that are already connected to the cloud. So on all these 8 aquaponic systems, we have sensors that are taking some data, so temperature, pH, oxygen, electroconductivity. Another important sensor is the water level, because you will see that in aquaponics, the leaking problem are one of the most important problems when you will design your system. So all in this aquaponic system, we have these sensors and they are sending data online. The next step of the aquaponic project is to create the smartphone application, which is able to visually to see the data collected by the sensor. And we are now working on this. So right now, we have some sensors in the aquaponic system. We send the data online to confront the model, the informatic model to the data. And we are also able to see the data produced by the aquaponic system in the smartphone application. And the next step will be to create a game based in this cell phone application. And we should release all of these tools by the end of 2021. So if you want to know more about the project, we can talk first, but you can also follow us on our website. And we also are present in different social networks. So I put the link for the different social network here in the presentation. And then I'm really ready to talk about your question.
Yeah, thank you very much, Pierre. Actually, I want to use it.
I hope so.
Yeah, so the first question is about if it will be a free application, yeah, for mobile phones. But,
So up to now, so when we will release the application in 2021, it will be completely free. But we are also thinking about how to make this application live across the time. So it may happen that within 4 years, when we won't get any European subsidies, we'll try to make a commercial application. And in that idea, all the educative system should be free. And for the rest of the world, we don't know yet how we will manage that. So it's highly possible that professional structure will have to pay something. And we already made a small commercial investigation to see who is interested to use our application, who is interested, who will accept to pay that. And what we have seen now is that the market is still too small to be able to pay someone to work on the smart aquaponic application if we only rely on the benefits done with the users. So at the beginning it will be free, and maybe after it will be paying.
Okay. And then there is a question about if there are big commercial aquaponic systems in Belgium, if they want to share their data to test the tool.
So I should go back. So what's happened with the professional aquaponics system is that when we start the project, so we were thinking they will be really interested to have the smartphone interface. So, but these guys now have some good interface to see the data of their system. But what they really like, it's the model. So they want to be able to carry out future simulation of their system to see what's happened if I put that amount of fish. What's happened if I heat a bit more my greenhouse or heat a bit less my greenhouse. So they don't really care about the full application itself, but they are really interested in the model to try different scenarios of farm management, actually. Then there are these, let's say, small professional aquaponics system and the education sector. And these guys are interested in the monitoring system, and they are more interested in the monitoring system than in the model. So what I understand is that the big professional will be really motivated by the model, and smaller will be interested by the application and the monitoring aspect.
Okay, thank you.
Welcome.
And there is a question about the position of the biofilter. So why is it between the fish and the vegetables?
Oh, can you repeat it?
Why is the biofilter between the fish and the vegetables?
So what is really important in an aquaponic system is to have the solid removal part. So the part where we remove the fish feces just after the fish tank, so that we don't send all the dung in the other part of the aquaponic system. Then, concerning the biofilter, we can place it basically wherever we want, because you don't see a significant difference between what is entering. How can I say that? What you need to do is when you have your water that go out of the fish part, somewhere between the water that go out of the fish part and the water that go in here, you needed to have your biofilter. But you could place the biofilter before or after the plant. It wouldn't change anything. But generally, we put it close to the solid filter because it's in the same room. So it makes sense for the location. And also, it's quite good to have clean water that go in the biofilter.
Okay. And with solid filter, you mean the mechanical filter, the one that has the biggest particles. Okay.
So we can imagine some other design, but it's the most easy to organize.
Yeah, basically it reproduces somehow what happens in a wastewater treatment plant.
Yes.
Yeah. Is any of the software under development open source? Will we be able to contribute?
So for now, the best way to contribute will be to use the application so that we get the data of your system. And then actually what will happen is that you will we will get the data from the sensors, but we will also ask to the contributor to write how much fish they harvest, how much lettuce they harvest, etc., so that we can make the connection between the model and what is actually happening in your system. So at the beginning, it will be the best, easier contribution that we can do. And it's interesting because it will be a win-win situation, since you will benefit from the tools and we will benefit for the data. And that would be one way. And concerning the model, the model itself will be open source, which means that you will have access to what are the equations of the model, etc. But the code itself, so the informatic script, we didn't identify yet how we will use it. I don't know if it will be open source or not.
Okay.
Which is actually the most interesting part, but it's also the most critical part.
Yes.
And in our ideas with the informatic team, we had the idea that the people will be able to add a block of model through the interface, but some specific user on request. But I'm not sure it will be done during this project by 2021. Just it will be a matter of time, of working time for us to do that.
Yeah. And then still a question about the biofilter. So what is the best design that encourages more of the nitrifying bacteria to multiply? What is the ideal pH and temperature for nitrifying bacteria? And is there a sensor water technique to track growth or existence for nitrifying bacteria? So first, the best design.
Yeah.
With the pH water temperature, yeah.
So the best design, basically, it's a big tank with water where you have a blower and some plastic sheet. So this is the most efficient, but you can also use some clay balls and a clay balls bed. And these are really good design, but for low-tech system. And if you are a gardener, I will invite you to use a clay ball system with your plant growing there and so on. If you are a professional, I will invite you to have this kind of big tank with a plastic ship and the air blower. So then with this kind of biofilter, according to your level of investment and what are the yield you are willing to have, you may also add some pure oxygen in the biofilter or in the fish tank. So putting pure oxygen in the fish tank will increase the yield, the fish stock density in the fish tank, and then it will increase the yield, but it will be much more costly.
But do you mean not the aerator, so really the oxygen gas like they do in intensive aquaculture?
Yeah, exactly.
Okay.
This is again a link between the business model the technical aspect. And this comes back to the presentation of Nicolas.
Okay.
So for the bacteria, the ideal pH and temperature are different from the fish and the plant. So I don't recall exactly what is the best pH for them, but I think it's around 7 or 8, I forgot. But for the temperature, it's much higher than what the plant and the fish like. So whatever happens, you will create an environment suitable for the plant and the fish if you are in one loop system, or you will create one environment really good for the fish part, and one good environment really good for the plant if you are only sending the water from the fish to the plant. And what will you do is that you will not create an environment, an optimal environment for the bacteria, but you will just size up the biofilter, increase the size of the biofilter, so that it can have a lot of bacteria, even if they are not working so perfectly. So this is the main idea for the biofilter. So if you adapt completely the pH and the temperature for the bacteria, you will have a better transformation of ammonia to nitrate, but you will not do it.
So basically, by offering a bigger growing surface to the bacteria, you overcome to this compromise situation that is not optimal for the bacteria.
Exactly. Alors, is there a sensor technique to track growth and existence of nitrifying bacteria? This is one of the saddest things of aquaponics. So there are some sensors to monitor ammonia, nitrate, and nitrates, but most of them are really expensive. So in our lab, we have a research sensor that monitors all the ammonia parameter, and it costs 20,000 euros. So except if you are a big aquaponic farm, you will not invest in this. But what you can find is some tiny sensor that you can just plug in the water and get the nitrate, nitrite, or ammonia level. But they are not really accurate, but it just tells you if you are in the good range or in the bad range. And then most of the professional farm have some spectrometer, which are a computer where you put the water there inside, and it gives you the value of nitrate, nitrates, and ammonia. And this costs 2,000 euros for a good one. So that's this is what professionals do. But still, it doesn't tell you how many bacteria you have in your biofilter, but it tells you if they are working well or not.
Yeah. And then basically how the nitrification happens. So what is used to decompose fish excreta to make it available for the plants?
So for this one, so I'm not sure if I will answer to that question correctly, but what I understand from the question is, what do you do with the fish, the sludge or the feces from the fish? So in most of cases, this is old school aquaponics, we remove all the solids from the aquaponic system. This is the old way, let's say, or the normal way. Nowadays, some people are taking this sludge and they store it beside the aquaponic system in water, and they blow some water there, and this will compost the solids and release some mineral element, mostly nitrogen and phosphorus. And then they reuse this fertilizer in the plant part. This is the first strategy. The second strategy is to take fish sludge in another compartment, but in a dry environment, and mix it with all the leaf, all the vegetable waste, and add some worms, and then there is a kind of vermicomposting of the fish feces. So these are two main strategies that we can find now. And they are implemented in some professional farm, but and we start to learn about this system, and scientific start to work on that, but it's still at the beginning of this strategy. And it's the future.
Okay, interesting. And then will it be possible to put the project of Smart Aquaponics on the GitHub and to let people from all over the world to contribute on writing and developing for free, which will reduce the cost of developing Smart Aquaponics?
I don't know what is GitHub.
I think it's something that data scientists use. Correct me, Marwan, if I'm wrong. Me neither. I'm not really familiar with that. But yeah, I guess the question is if people from all over the world can contribute and to the script itself.
For now, it's not. We didn't think exactly about this. Because we didn't completely design the future of the application, but this could be, we could integrate that in our internal discussion to see if we could use some contributors, external contributors. But whatever happens, if we use this strategy, we will try also to have a kind of, we will need someone that see what is relevant or not, I guess. But I think it can be a really good strategy. I will copy paste this comment in my notebook.
And then I think, Marwan, I guess you can write directly to Pierre because I saw another comment that you wrote. So
Okay.
Pierre is a very valuable person, so you can write to him directly. And then we have a question about if you use other fruits and vegetables in your simulation.
Yeah.
And can there be multiple species simulated at the same time?
Yeah,
So
sure.
are you thinking of letting the user add fish, fruit, and vegetables models which are not included there?
So concerning the fish, there are for now 10 fish species. Included the most common, so goldfish, trout, carp, tilapia. There is also sturgeon there. There is also a crayfish, and I forget the 3 remaining fish. And for the vegetable, I think we have 8 vegetables for now. We have tomato, eggplant, coriander, basil, lettuce, and few others, forget which one. And so in the model, you can indeed take 10 tomatoes, 20 lettuce in the same time and see what's happened, or put 10 lettuce every week to make a cycle to see how to try different scenarios actually. So you will be able to do that. So concerning the last, and to introduce a new species, actually it's quite, technically it's easy because we just have to integrate the parameter, the favorite parameter of the plant or the fish. But what is complicated is to have these parameters. So once someone has done the job to identify what is the best temperature, what is the best electroconductivity for a plant, it's easy to add it in the model to have a new species. But it's difficult to have this work. Yeah, we can also try different kind of food. So if you have all the different food are characterized by their protein content, carbohydrate content, assimilation capacities, and so on. So when you buy a new food, you can just copy take the information from the food, which are generally on the pack, and add them in the model so that you can try virtually different kind of food.
Okay. And then we have a question about the density for the fish, in particular for tilapia, when they are not fingerlings anymore, so 3 months, for example.
So actually, this will depend mostly to the aeration and to the size of the biofilter and your capacity of aeration of water. So if you are in a high-tech system with pure oxygen blower, etc., you can go to more than 100 kilogram per cubic meter. In this case, in a low-tech system, we generally go between 10 and 20 kilo per cubic meter. So what I recommend is to put enough fish and to put some fish and anticipate that when they will be big, they will be 20 kilo per cubic meter. If you have only one tank. If you have several tanks, what we do is that we put a lot of small fishes in the first tank, and when they grow, we split the group in two and we put them in other tanks, so that we can try to have a constant fish concentration in all the tank. And these are traditional techniques that we use in aquaculture. Alors.
Yeah, it seems, yeah, then comments about GitHub. Yeah. Some sort, now we know, it's some sort of a Google Drive, but for thank you. And then it seems there are no more questions. But I don't know how quick it is to answer to this, but how basically you had to teach your software, your program in order to do the forecast. I mean, how did you do that?
What we did, so we have a colleague which is doing his PhD on that actually he collects all the kind of equation and model that are existing in the literature to describe the fish growth, to describe the plant growth, etc. So he didn't create any model, but he assembled different models. So he has a model of the fish, and he said, this model explained that the fish grow when you give him some food, and when you give him some food, it will release some nitrogen in the water. And the fish will grow less if the temperature is too high or too low. So what we will have is that for each element, we have some limiting factor that limit the growth of the plant or of the fish. And these are equations that are available in the literature. So what my colleague did is that he found all these equations, put them in one model, so that all these equations are already validated by someone else. So this is the first step. So with this model, it's a generalistic model, and it gives something quite good. It's not very accurate, but it's good enough to simulate and have a good appreciation of what's happening in an aquaponic system. So the next step is that with the data that we collect from the aquaponics, from the actual aquaponic system, so the sensor data and also the production data, we can fit the model, which is actually adapt the model so that it fits to the reality. And this is a programming process, and we can fit this for different kind of farm. I don't know if I replied to the question.
It was my question, so yeah. Yeah. So it seems we don't have more questions.
Good.
I just want to share once again my email, because basically in our project now we have organized different seminars and then webinars starting from last December. And every time we started from the introduction to the aquaponics, and then we are treating different topics. We are going more and more into the advanced topics. So we are sort of building a path, let's say, within the aquaponics. So if you have particular questions about the next topics that you want to listen to, please write me. Also, if you are a professional or a student and have any ideas, you're welcome to write to me, and we can see how we can continue our project. But for today, I mean, it was really super interesting, Pierre and Nicolas. So I thank you very much. And also, I thank you all the participants, because it was very nice also to have this discussion and having a lot of questions. So I thank you, everybody. It was really a learning moment for me, and I hope everybody thinks the same. So yeah, Pierre and Nicolas, for any questions, I think we can write to you, right?
Yeah, definitely.
Yeah.
And I guess I will share both this webinar and your presentations in our webpage.
Thank you.
Thank you.
Okay, so thank everybody once again, and I wish everybody a nice day. And hopefully we keep in touch.
Thank you very much to all.
Thank you very much for the organization. It was really well done.
Okay.
Yeah.
See you soon. Have a nice day.
See you soon. Bye-bye.
Bye. Bye.
Are we still online?
Yes, I just read the chat.